So welcome to another session of Everyday Mathematics. Here at Everyday Mathematics, we always say we do enjoy solving the harder problems, but above all, we also see and appreciate the beauty in the simpler problems. So today, our problem comes from MIT 2024 Integration B Semifinals number 1, problem 4, which is the indefinite integral of cosh or hyperbolic cosine squared 3x hyperbolic tangent times the hyperbolic tangent of 2x. So very interesting problem. Before I jump into the solution, I'd like to thank our subscribers. Thank you so much for your support. We don't take your support for granted. It is your support and motivation that keeps us going. For our first-time visitors, what we do here at Everyday Mathematics is we go about and around and look for interesting problems. We try to solve them. When we get a solution, we come back and share with you. For our repeating visitors who haven't subscribed, our encouragement to you is please do consider subscribing to our channel. Then now moving forward to the solution to this problem. So one thing that I would like to remind our viewers is that a hyperbolic cosine or cosh x is the same as e to the power x plus e to the power minus x over 2, such that cosh 3x is the same as e to the power 3x plus e to the power negative 3x over 2. Now, if we're now squaring cosh 3x, that means that we have e to the power 3x plus e to the power minus 3x over 2 squared. That becomes a quarter of e to the power 6x plus 2 plus e to the power negative 6x. And so if you separate e to the power 6x and e to the power negative 6x, bind that together and divide by 2. And then this 2 is divided by 2 so that we're left with a half outside here. We now get a representation of cosh 6x plus 1. So a half cosh 6x plus 1 is the same as cosh squared 3x. So we can now bring this into our integration. So integration of cosh squared 3x or hyperbolic tangent 2x is the same as integration of a half into brackets cosh 6x plus 1 times hyperbolic tangent of 2x. So that eventually now we have pulling the constant half out, we have a half times the integration of cosh 6x times this multiplied by this, right? And then this multiplied by this. So we have cosh 6x times hyperbolic tangent 2x plus the integration of hyperbolic tangent 2x. So we can now separate this into two separate integrals such that when we expand the hyperbolic tangent of 2x, which is hyperbolic sine of 2x or sinh 2x over cos 2x plus half of the integration of sinh 2x over cos 2x. And now next thing is we can just punch the cos 6x and sinh 2x in the numerator and cos 2x in the denominator for the first integral. And then now as we see here, sinh 2x is the same as half the derivative of cos 2x. So in the numerator, we have half times the derivative of the denominator. And we're going to see there's a reason that I have expressed it this way. We'll see why I'm doing that. Now I've separated this into two separate integrals. We have the blue integral and then we have the green integral. So going forward, cos 6x sinh 2x is going to play around here. So cos 6x is the same as e to the power 6x plus e to the power negative 6x over 2, and sinh 2x is the same as e to the power 2x minus e to the power negative 2x over 2. So when you multiply those together, we have this times this, we have e to the power 8x, and then this times this, we have e to the power negative, this times this is the same as e to the power negative 4x. And then going to the negative side, this times this, we have minus e to the power 4x, and then this times this, the power is the same as minus e to the power negative 8x. So we can bunch these and this, and then we can bunch this and this, right? So that we do have now e to the power 8x minus e to the power negative 8x minus brackets e to the power 4x minus e to the power negative 4x, all divided by 4. So we can now separate that by pulling half out, and then each part here is divided by 2, so that we see here we have sinh 8x, and then here we have sinh 4x. So this cos 6x sinh 2x is the same as half sinh 8x minus sinh 4x. So plugging that in to our integral, in place of cos 6x and sinh 2x, we have half of sinh 8x minus sinh 4x, and then keeping the denominator as it is. What that means is that we have a quarter, because this half goes out, we have a quarter of 2 sinh we have sinh 8x minus sinh 4x. Now, I won't go into the details, but sinh 8x is the same as twice sinh 4x cos 4x, and sinh 2x is the same as 2 sinh 2x cos 2x. And now the sinh 4x can be further be expanded as shown here, which now means that the expression here is the same as 4 sinh 2x cos 2x cos 4x minus 2 sinh 2x cos 2x. Now this and that, sorry, apologies, the rest is, but we are meant to divide this. So these two cancel, so the denominator disappears, and now we have a quarter times the integral of 4 sinh 2x cos 4x minus 2 sinh 2x. And then obviously the green integral remains as it is. Now since 2x cos 2x cos 4x is the same as e to the power 2x minus e to the power negative 2x over 2 times e to the power 4x plus e to the power negative 4x over 2. And so when you multiply that together, we have this times this, we have e to the power 6x, and then this times this, we have e to the power negative 2x. This times this is negative minus e to the power 2x. And then this times this is same as e minus e to the power negative 6x. So we can bunch that, and then that can also be separated out. And so we have half e to the power 6x minus e to the power negative 6x divided by 2 minus in bracket e to the power 2x minus e to the power negative 2x over 2. So we see here we have sinh half times sinh 6x minus sinh 2x. So we can now take this and plug it in place of this expression here. So that means that we have, in place of this, we have 4 times a half sinh 6x minus sinh 2x minus 2 sinh 2x for the blue. And then the green remains the same. So what you can see here is divided by 2 is 2, divided by 2 is 1. And so we have a quarter times the integral of 2 sinh 6x minus 2 sinh 2x minus 2 sinh 2x. And then the green integral remains as it is. So we have a quarter times the integral of 2 sinh 6x minus 4 sinh x, branching this and this. So these are readily integratable expression, and then this half here now multiplied by this half here means that this is a quarter. Now this here definitely is the same as, because the derivative of cos 6x is the same as 1 over 6 sinh 6x. Now we have this, now we go backwards, and so we have a half, because it's 2 and it's 4 results. 2 times a quarter is a half. And then we have 1 over 6 cos 6x. And then we have this 4 and 4. 4 times a quarter becomes 1. So now we have just this to integrate, which is minus a half cos 2x plus a quarter. Since this is the numerator here is the derivative of the denominator, this becomes natural logarithm of cos 2x plus the integration constant, right? Now we can simplify this further, and we say that that is 1 over 12 cos 6x minus a half cos 2x plus a quarter, natural logarithm of cos 2x plus the integration constant c. So this is the answer. It's been an absolute pleasure walking through this problem with you. I hope you had fun following along. If you have any question, please feel free to leave a comment or a question or a suggestion that you may have, so that we broaden our horizon, and then we increase the engagement across board. Thank you. Until next time, tutor Luca la question 4. Adios. Kwaheri.